Hey guys, so today I'm going to be going over the notes for our double replacement reactions, aka the wife swap reaction. So a double replacement reaction is when the anions, or the two negatively charged particles in ionic compounds, swap places, meaning that they're exchanged. Okay, so here is the alphabet soup for a double replacement reaction. So we have AB plus CD yields AD plus CB. I've color coded this, so pink is positive and green is negative. So you're switching the negative ions, all right? So just a little note when we're dealing with double replacement reactions. One product needs to be aqueous. That's what this AQ stands for. And one product needs to be either a solid, liquid, or a gas. In order to figure this out, we need to look at our solubility rules, which are on the bottom of our periodic table right here. Okay? So, pause this video, go back, take your notes, and then I'm going to walk us through an example. So here's the example. I have, to clear some space, but I have potassium iodide and lead 2 nitrate. Okay, and they're both aqueous solutions. I'm going to mix them together and they're going to form two completely new compounds. So the first thing you need to do when you're working with these types of reactions is write the metals in the same place. So K and PB are going to stay in the same spot. Now I need to switch their partners, right? So if this is B, B is going to end up with C. So in this case, PB is our C. So it's going to be PBI. This lead has a +2 charge, and iodine always has a -1 charge. So I will have a final formula of PBI2. Now we need to figure out what's going to go with K. So K is A. A is going to end up with D, which is NO3 for this reaction. K, or potassium, always has a +1 charge, and nitrate has a -1 charge. So a +1 and a -1 cancel out to 0, so I don't need to add any special subscripts. So this is where I need to look at my solubility rules. And our solubility rules are organized by our anions. Okay, so I need to look for NO3 and iodine. So looking here, at our solubility rules, I'm going to start with the mainly soluble side. If it's soluble, that means it will be aqueous. So all NO3s are soluble. Bingo, we found our first one. So our KNO3 is going to be an aqueous solution. So inside the parentheses, I'm going to write AQ. Now we need to do the same thing for I. So I'm again going to start with our mainly soluble list, and I'm going to try to find iodine. So NO3, acetate, chloride, bromide, iodide. So all iodides are soluble except when they're with silver, mercury, and lead, specifically lead 2. So PBI2 is one of the exceptions, and it's also the second product we have. So this means this is going to be a solid because it's an exception. If this was any other metal, it would be aqueous. So our final formula, or our final equation, is this. Now I just need to balance it. So I need to balance my iodides. So I'm going to put a 2 here and then add a 2 here, and we should be balanced. So all in all, these are our double replacement notes. Again, pause the video where you need to and just take your time filling out your notes.